My wife even thought, I was like, where's your wine shirt? I'm like, I don't even have it.
No fanny pack?
No, I don't have a fanny pack. I wish I did. Those things are awesome. I put markers in there and my
Why don't you have one? We're gonna
buy one.
calculator.
We're gonna buy one.
When's your birthday?
When's your birthday?
December.
Perfect. I'll get you an early birthday present.
You gave me a fanny pack. I'm seriously going to use you to make fun of me. So, all right. So here's the idea. Right? All right. Just for this class, I'm going to do it. All right. Now, what I want to talk about is the graph. There's a couple different problems that I want to make sure that you understand. So, one of the problems they're going to give you is, I think it's like the first couple in the homework, where they give you like 2 through 12 evens.
Yep.
What they're doing here is that they're going to give you individual coordinates. So problem number 2 is like 5, comma, negative 2, and number 4 is 1, comma, 7. All I want you to do is take all those problems, put them on one single graph. I will provide you graph paper today for that. So it's, through all these, so 5, negative 2, remember right down to the first number you have to pick the elevator, the second number you go up and down in it. Just keep that in mind. They're going to give you a bunch. Do we feel comfortable with graphing coordinates?
Yep.
Like that's old school stuff. You probably did a ton in Algebra 1 and Algebra 2. I just want to make sure you understand like what you need to do. Because last year I had a bunch of questions like, where do I have to put a dot on each individual graph? No, all these go in one graph. You're gonna have like 6 to 8 different dots, something like that. That's fine. Okay. All right. Let's move on to the next one.
Can we connect them?
No, don't connect them. Just individual dots. Good question. The rest. All right. Second thing. The second problem is they're going to give you a picture and they're going to ask you a series of questions about it. So, for instance,
Who drew the picture?
they're in the book, so they're pretty decent. All right, so let's say this is my problem, something like that. They have arrows on it and everything like that. All right, so here's my graph. Sorry if you can't tell where those things are going. It's from basically negative 5, 2 and on. That's horizontal. Kind of curves up to negative 2, comma 5. And then it goes down, yeah. Then it goes down to 2, comma negative 1, and then it kind of curves up and goes to infinity. All right, now they're going to ask you a series of questions about this. So here's the question. One of the questions, and let's say this is this graph. They have this usually labeled off the side on your picture. This is f of x is some type of function, and my graph is something like this, where they might ask for what is f of negative 5. Okay, so what that question asks for, it asks for the number that's on the graph at that location, like where the curve is, where the red line is sitting. So this number that they're giving you here, this number is your x number. Okay, so it's kind of like negative 5, and what they're asking for is they're asking for the y number that's coming out from the graph. That's all they want. They just want the number. You don't have to give me a coordinate. It's a single answer. It's like a digit, right? So here's the idea. If they ask for negative 5, go find negative 5. So 1, 2, 3, 4, 5. What's the answer at negative 5? 2. There's your answer. Like, that's what I want. I know that this is the coordinate they might print in the back of the book. All I want is that number. Does that make sense? Let's do another one. Let's go with like f of let's go f of 1.
Look at the slush.
So f of 1.
Look at Cole.
What?
He looks like he's Australian.
He looks like he's Australian.
You look Australian.
So, okay, f of 1. Where's my answer going to be? 1. Okay, so yeah, so everyone's saying, so f of 1, you got to find 1 on the x-axis, and it wants to know the number where the curve's at. It's about 1. Try to give me the closest number that you can. If it's in the halfway point, you can give me the decimal. I'm going to say it's at 1, 1. That looks good to me. That's the number I'm looking for. I'm not looking for a coordinate, I'm looking for a single digit. Do we feel comfortable with that? Okay, I think you have like 5 to 6 of those where they just give you a graph and they ask me a serious question about it. The last type of problem, this is my third type now. The third type of problem now gets a little more tricky. All right, I'm going to leave this graph on the board here. All right, so I'm going to use this for the last, I don't know, it's the last 2 or 3 problems in your homework. They're going to ask you a series of questions about one picture, and if you look at the instructions above the picture, they have like an A, B, C, D kind of a thing. where it might ask for like, what's the range, what's the domain, what's the maximum point, what's the minimum point, what is the value of f of 2, right? They might ask for different numbers. So I'm just going to give you a series of questions here. So A, I want the domain. So we'll go through each part of these. Domain. Part B, I want the range. C, I want the maximum. And letter D, I want to know what f of 2 is. Okay, so it's kind of like a very similar situation we just did a little bit ago. All right, domain. Domain are all the x numbers. So when I'm looking on this graph, is there any breaks in the graph at any point?
No.
No, it's pretty continuous, right? It's flowing from the left side to the right side. So since it's continuous and there is arrows, this thing is going over here. I always go left to right, by the way. It's starting at negative infinity. Negative infinity is a direction. And it's going up to positive infinity, and it's never stopping. It's actually continuous the entire way across. That's your domain. Negative infinity up to positive infinity. Now, if there was any breaks in the graph, you'd tell me where it would stop. Maybe it would go from negative infinity up to 5, and then maybe from 7 it'd go up to positive infinity. Like you might have to give me those sets where you can write it like this. X is less than 5, but greater than negative infinity, right? You could write it like that. I'm totally fine with that. Maybe it's equal to 5. Maybe there's a solid dot there, so you put a little bar underneath it, because there was a solid dot at 5.
Wouldn't it be greater than or equal to negative infinity?
No, it's greater than, it's just a direction. We don't actually put an equal sign on it. So it's like, it's not a number. If it was like a digit, like 1,000, I could put an equal to. It's just a direction. So it's not a number. That's why I don't include it as equal.
I just showed you an ass.
All right. But that's domain. Remember, domain are all x numbers, so it's pretty straightforward. Now, what about range, y numbers?
Y is greater than negative 1.
Okay, so on the y numbers, you're absolutely right. We're starting at negative 1 here, because remember, I'm using the y numbers. I'm starting at negative 1, and I'm going basically up. So, yeah, so I would say x is greater than or equal to negative 1. That's what I would say, because there is a solid dot at negative 1. Does that make sense? Now, I don't care how you wrote it. Like, I write it like that, where I always put the lowest number on the left. If you want to write it like this, where x is greater than or equal to negative 1, I'm fine, it's the same thing. I want you to get used to that. There's something else we're going to look at later on, where we're going to look at sets differently. But does everyone understand how the range is working? We're going to look at a different way to write that in the next section. It's just one of those things I want you to know, like the easy ways to write it right now. But again, range or y numbers. Start at the lowest point. Now, if there's an arrow going down, you'd start at negative infinity and go up to positive infinity. But this thing, like, it stops at negative 1. Okay, what's the maximum to this graph? Yeah, there is no maximum, right? It's not applicable. The reason why, you're absolutely right. It went towards positive infinity, right? So this thing has an arrow going up. There is no maximum. So, there is no maximum because we are heading in the direction of infinity. Infinity is not a number, so there is no maximum to this graph. You can put, no maximum, or, I don't know how the book would write it. I think they just say maybe it's not applicable or something like that. I would say just no maximum. All right, what about f of 2? F of 2. Where is this graph going to be at f of 2? Yeah, so here's 2, right? This is the number 2 for x. It's at negative 1 at that point. Okay, so you just give me the number where the graph is currently sitting at 2. Does that make sense, like the numbers they want you to give?
How do we know it's not up to?
You mean? So what you do is you go find 2 on the x-axis, right? Go find it. And then just go figure out where the curve is. I don't care where it's at. So I'm looking for where that curve is sitting. So maybe your curve is up here somewhere. You just go find 2 and then go find where you're at. That's all I'm doing. Does that make sense?
I get it.
Okay, yeah. It's really weird to think about that. You're going to find where 2 is on the x-axis and then just go find the answer where the curve is sitting. Okay. So it could be up, it could be down, I don't know. You gotta find it. Okay, questions at all about the basic concepts today? These are the only problems I really haven't discussed. We've talked about tables, I've talked about intercepts, we've talked about graphing a lot. how to plug in numbers into different functions. That's what we've done the last couple days. It's one of those things you just need to see it. Okay, homework's on the board. It's page 143, 159. There's 2 different pages. It looks huge. It's really not. I mean, those first few problems, 2 through 12, it's literally graph a dot on a graph, and you just have multiple dots put on one graph. 14, 18, you're drawing one picture for each of those with a couple dots each. 20, 28, I think it's a very similar situation. You're graphing so dots, not lines, but just dots on this graph. 29 through 40, they have you look at tables and answer a bunch of questions about that table. 159, they're gonna have you do the stuff I'm doing here. Like what's the domain, what's the range? What's this point f of 2? What's, they're just having you ask a series of questions. The only thing I would think, the only number you have to worry about, I think is 81. That's like a tricky problem. But that should not take you very long. I'm betting if you actually start working, you'll get it done before you walk out of this room. I'm not
Thursday though?
Yeah, it's due Thursday. They have a couple days. I'm gonna give you graph paper. This graph paper you can staple right on the back of your homework. You will need a separate sheet of paper. And this will help you graph. There's only select few problems you're graphing. And you only need one.
Or can I go utilize the bathing room?
Yeah, let me
Isaac,
do
why
this.
are you using the bathroom?
No, don't answer that.
Put it on the password.
No. Don't
What
answer.
specifically?
Nope. Because if you tell me, I'm not gonna let you go.
Here, whisper it in my ear, I'll tell him.
What's that? You have to go.
No, stop.
I didn't say anything.
I think it's a repeat of last time.
Oh, that scenario.
Button up your shirt.
You see what he wore like yesterday?
Button up your shirt.
He wore a